Good morning everybody and welcome again to our course on Introduction to Mechanical Micro Machining. Today we are going to start a new topic and that is related to machine tool components. So, before we go into detail of this course particular topic, let me tell you what things we are going to cover in this case, because we know that machine tool is very important component when you operate or when you do some type of machining on a different type of workpiece, and the tool is also one of the parts out of the different components of the machining process. But machine tool has one particular importance, that what accuracy you are getting onto the workpiece, mostly it is dictated by the construction of the machine tool, which type of material you are using on that, what are the different type of specification you are considering, that is mostly related to the precision of the different axes. Everything will play important role in making a component as per our design requirement. So, we will go through the different component of the machine tool, so that we can understand the role of each and every component and how they are important in getting the required geometry of the different workpiece. So, we will go through the construction of the machine, then the spindle, then different type of axis, what type of bearings we are using, why we are using those types of bearing, and what are the errors, because that is important, because when you are making a or constructing a big machine, at that time you have to also look into the flatness, perpendicularity, parallelism. So, those things will play important role when we are talking about micro machining. So, let us go through this particular topic and let us understand that how different components are important for making a good component. So, those things are there. So, different between the machines. So, first let us go through the things, that how the machines are evolved from a conventional machine to the very high precision machine. So, if you see this first machine, that is a conventional milling machine, we all know, and this is the CNC milling machine, and many times we can call it a machining center also. So, now how these two machines are different from each other. So, here if you see this thing, one is the feedback and closed loop control. So, here in the conventional machine, mostly what we do, that operator has a more role on this particular machine. So, operator is engaged more in conventional machine, correct. Why it is so? Because in conventional machine, operator has to do all the setups and everything, and during machining also he has to operate all the things. There are automated feed is available, but mostly many times operator himself will do all these operations, that moving the job down and then do a small cutting, and many times it has to be performed in this case. So, engagement of the operator is more in the conventional machine, while here it is mostly on the part program. So, operator has to write a one part program depending on what type of workpiece he wants to make, and then the machine will take that program in a controller, and then control will perform all the movement of x, y and z axis. Another thing is that this one is the closed loop control, that is CNC machine, because we have feedback devices installed in that. Some machines also come without any type of feedback control, that means you are not using any type of encoders. Then machine control, that is a programming, because in conventional machining we do not do any type of programming, that means movement of the axis is purely depend on the operator or the machine specification, the way you can actually engage the automatic feed and automated movement, but that is not that much precise compared to the CNC machine. And we do not use any program, because when you are operating a CNC milling machine, we go through the GNM code. So, mostly it is known as GNM code for part program, correct. So, that is the one of the differences, and then other than that, Accuracy of slides and guideway, that is also important, because when you are working with this machine, conventional machine, you are getting little bit higher side of accuracy in the guideway and slide. That means, whatever we are moving in different axis. So, these are the things. So, x and y axis, and vertically also we are moving the spindle. So, that is z axis for spindle, right. So, what is the straightness and what are the perpendicularity between this x and y axis, everything dictates the precision of the machine. Automated operation, structural stability. So, those things are different in between the conventional milling machine and the CNC milling machine. Operation is automated in CNC machine, automated in the sense that once you feed the program inside this controller, then controller will execute the program line by line, and depending on the movement of the axis in XYZ direction, you can get your part machine very easily. So, the automated operation in the sense of the operator engagement during the machining operation, which is very less here. Only role of the operator is to look into the screen and understood that everything is going fine during the machining operation, right. So, now we understood the difference between the conventional milling machine and the CNC milling machine, but again there are some limitation of the CNC machine when you are working at a micro level, because there are many components which may not give a satisfactory results when you are working at a micron level. When you are working in the tens of micron or hundreds of micron, sometimes this is also not enough. So, we have one other category of the machine, that is called micro milling machine. We will have one demonstration class on this CON machine, which is we have in our lab. So, we can understand the different components and how this machine, micro machining machine, is different than the conventional CNC machine or the normal machine which also available in the lab. So, now let us see the how these things are different. Now, again the same thing, feedback in closed loop control, but that is different here. That means, when you are talking about hundreds of micron, that means this closed loop control has a encoder feedback of a 0.1 micron of encoder feedback, but that is not the case here. Many times it is in terms of 1 micron or the 5 micron of the encoder. Sometimes encoders are not available at all. We have some machines where the feedback controller is not available, that means movement feedback is not available. Accuracy of the slides and guideways, that is when you are moving in x and y direction, what particular accuracy you are moving it. That means, suppose you want to move from one, this is your starting position, and you want to move to this position, that is your target, correct. So, from here to here, when you are reaching, how close you are reaching here, that is given by the accuracy. So, suppose you want to move to the 10 mm, then you are moving to 9999 or 10.0001 mm. So, how close you are reaching to the 10 millimeter, that is dictated by the accuracy of the slideways. So, those things are different, because we know that after each and every digit your cost is going to very high. So, up to which particular digit you want to stop, that is dictated by the how much money you want to spend on the accuracy and the feedback controller of the machine. Structural stability is more important here, because even as few microns of vibration here and there will destroy your whole component. So, rigidity of or the structural loop stability should be extremely high in this particular case, and which is not the case of the first two. So, this should be very high, and then only you can get the machining at micro scale. So, machining at micro scale, correct. Size of the cutting tool and working area, because now we know that whatever tool you can use here at this machine, tool for machining for this machine and these machines are same. Right, mostly you can go up to 1 millimeter here also, 1 mm diameter, and that again depend on the run out of the spindle and the RPM of the spindle, but less than 1 millimeter or 0.5 millimeter it is creating problem here, and here again it will be very high. But between these two the difference is very large, because here it is reported that you can machining is done with up to 20 micron of diameter of cutting tool. That is very difficult here, because getting a 20 micron tool itself is very difficult, and when you are putting 20 micron tool in a conventional spindle, you have to extract some of the very important specifications from the spindle, that is basically a run out of the spindle, dynamic and the static run out. We will discuss these parameters much detail, but right now run out means what is the wobbling of the tool with respect to the axis of the spindle. So, that is very important, because if it is more than 20 micron, then obviously you cannot get any type of machining out of that part, because we are using a very small cutting tool here. So, basically that whatever is the run out, whatever the diameter of the tool you are using, your machine should expect that 10% of that particular should not be run out of that. So, if you are using a 20 micron tool, then you expect that its run out should be less than 0.2 micron. So, that is what is expected from the machine. Working area is again very less, because obviously we are not going to do machining on a large scale, mostly into 100 by 100 millimeter is enough for doing most of the work in this case. But in these two machining machines, the CNC milling machine and the conventional milling machine, where you have very large amount of or large size of the component, and you can easily get machining done with a required geometrical specification. But here our specification in the size and the dimension of the components are very small, and we have to create a very tight things between the all the structural stability and the accuracy of the slides and the feedback controller. So, these are the differences between the three different categories of the same machine, but if you see the size of the machines are almost same, there is no much difference in the total volume of the machine, that is in the area multiplied by the height of the machine. But the systems which we have installed or which is available in different machines are different with respect to the component which you are going to cut through these machines. And you can see that this is the size of the cutting tool, and this is the point of a ball point tool, and this is the cutting tool, end mill cutter, and you can understand that how much precision is required to fabricate this tool is, that is the first thing. And where you are mounting, the precision of the spindle is also play important role when you want to extract the reasonable amount of work out of this particular tool. Now, what is the circle of technology? That machine is made up of individual components. Now, if you know that machine is consisted of many type of different components, it start, and contacting point is the workpiece and the tool contact point, that is called interface point. But if you continue that, means the workpiece is connected with the workpiece holding device, that is fixture is connected with the x and y table, and then if you continue in this direction, you are getting a different components here. Now, if you see this particular thing, so this one is the x axis and this particular thing is the y axis, and this one is the z axis spindle, and these are all three are the linear movement. And once you attach this particular spindle here, then you will get the spindle rotation, correct. Then for moving of this thing, then you have to assemble all the components, and then only you can operate the machine. So, it has a many different components, and that will create a problem in getting the required result, because these are the all the joint part. So, if one component is not at 100%, the machine may fail at the producing a quality parts. Now, you consider that everything is working fine, but your z axis of the spindle is not up to the mark. So, whatever you have some backlash here, that means suppose you want to move 10 millimeter down, it is moving 9.54 or 10.5 or something like that, then it is creating problem. If everything is fine, but you are not rotating the spindle up to a required RPM, then it is creating problem. If z axis is working fine, but you have a problem or issue with the perpendicularity between the x and y axis, then it is a problem. You want to do a straight cutting, but you are getting an incline cutting. So, to get a part completely 100%, you need a 100% output from all these components. So, that is why the circle of technology is important. That means, each and every part should behave or should give 100% of their whatever the required operation, then only you can get the things done. So, micro machining requires a tight quality relation within every machine component. So, that is what we have seen here, that even a few microns of movement or the disturbances between the different things, that is enough to destroy or reject the component which you want to intake from this micro machining center. So, that is why you have to be very careful in getting this thing done. That means, the perpendicularity should be maintained. If perpendicularity is maintained, but then the flatness is not there, then there are problems, because you want to cut something like the straight line in this case, and because of this x and y is not exactly parallel and it has some angle theta, then your tool is right now here and you want to cut from this to this up this much distance only, and this is the depth is same from here to here. So, this is d and this is also d, but because of this angle what you are doing, you are cutting something like this. So, this will be d 2, that is not exactly d. So, there are problems with many things here, because one, this part is not as per the dimension. So, part will be rejected. Another thing, that your speed, feed and depth of cut is decided because of the depth setting. How much depth you are putting it, depending on the feed rate and speed are decided. But now your depth is variable. Once it reaches here, your tool is going inside up to this much, but your parameter setting is calculated based on this much depth only. So, your tool may bend also, it will break also. So, you are end up with the breakage of the tool also and rejection of the workpiece also. So, each and every small things you have to be very careful in designing the component, and again you have to also see that after 6 months or after 1 year your machine is exactly giving the same thing whatever you are doing. So, that is called calibration of the machine, that is very important in micro machining domain. Right. So, now this is the example that we have discussed here, that if there is a slight quality issue with the spindle, quality issue in the sense that it is either not rotating exactly as per the RPM, or it is not aligned actually exactly at the center. So, this is you consider the center of the z axis, and this is you consider the axis of your spindle. Then this is the angle theta, that means you are not exactly matching this part. So, whatever tool you are putting here, let it be a few micron degree only, micron degree or micron radius, that is also enough to bend your tool or not getting the required result out of that, and ultimately your tool will be broken. So, those are the quality issue, then chances are it will have the negative effect on the part. Sometimes you get the machining done, but it is not exactly as per the specification, and sometimes it is a total failure. So, either workpiece is not acceptable and the tool is also broken before you do further operation on the component. So, circle of technologies, that means you need a full circle here. So, this is your content, this is your tool and this is your workpiece. So, both things should match. So, if any of this component is not here, so your tool is here and then you will reach the workpiece here. So, whatever is this distance, that will be decided by this contribution of all the different parameters. So, we need a starting point and end point should meet. It is not like that we are starting from here and we are ending at some different location. So, how close you are reaching from starting to end point, that is decided by the different component, the role of the different component during machining operations. Characteristics of a machine tool. So, now the size and quality of the micro product depends on the property of the machine tool used to produce them, that is mostly the accuracy and the dynamic performance. Dynamic performance means when it is in static we are not utilizing the machine, but the static deformation is also important, but that will take some time. But when machine is in operation, at that time the different components are in motion, that is mostly in XYZ slide, RPS, spindle is also rotating. So, there are many movable components. At that time how the machine behaves, that is also important, because that is the real life situation of the component. So, capability and quality of the machine tool is related to the size, accuracy, surface roughness and dimensional repeatability. Size of the component, that means up to what size you can cut the component and how precise you are cutting. Accuracy means if you are getting 10 by 10 size of the component, and whether you are getting exactly 10 by 10 or you are getting something different. So, that is detected by the accuracy. Surface roughness is important, because if your dimension is exactly whatever is the requirement or within the acceptable limit or tolerance limit, but still you are getting a rough surface, right. If surface is rough surface is not acceptable. So, to get this thing down, what you have to do, that you have to optimize the parameter, for reducing surface roughness. Correct. So, there are many issues. Dimensional repeatability is also there. Suppose you in one component you are getting this dimension, you want to continue with the 10 same type of components. So, whether you are getting the 10 components, suppose you want to make 10 components similar dimension, then are you getting the same dimension or same result every time? That is given by the repeatability. The same results every time, correct. So, everything is dictated by the different component responsibility during machining operation. So, what things are important? First thing important is stiffness. Stiffness means resistance to deformation under loading. When you are load, this is suppose a cantilever beam and you are loading at the free end, how much it will deflect, that is dependent by the stiffness. So, higher is the stiffness, lower will be the deflection. So, this is D. So, it will go little down, very less down if the stiffness is high. That means flexible, it is opposite to flexible. Flexible means if you are giving a small force, your things will bend very quickly or without any type of resistance. So, that is why stiffness is more important, because we have a physical contact between the tool and workpiece, right. So, our tool is here, workpiece here, and we have tool which is moving in this direction with a depth of cut inside. So, basically you want to remove the material from this part. So, this much amount of physical resistance is also provided from the workpiece, and tool is also providing the enough amount of forces. So, under this particular condition, how much is the stiffness? Suppose you want to move from here to here, whether you are exactly cutting in the same direction or your workpiece is bent in this direction, and sometimes tool is also coming out of this direction. So, that is decided by the stiffness of the different component of the machine tool. Another thing is the thermal stability, because temperature has a very important role in the micro machining especially. Even a small degree change here and there will create a problem, because we know one parameter, that is called coefficient of thermal expansion. And it is mostly given in terms of 10⁻⁻⁶ by degree centigrade in most of the metal. That means, with a 1 degree of centigrade change in the temperature, how much is the expansion or the contraction of the component. Mostly it is in micron, but if it is in micron, you can understand that we are also working in the micron domain. So, small change here and there, suppose you are changing, suppose we are putting our machine in a open environment, and we know that we have a temperature distribution in the different season. In the winter, sometime it is reaching to 1 to 2 degree, 2 to 3 degree, and summer it is reaching to 45 degree also. So, such a large difference in the temperature also play important role. So, this is very large, but we are talking here degree change in the 1 or 2 degree. So, even if you keep inside a envelope, still you have to maintain the temperature, because each and every components are physically clamped together. So, suppose this is the one component, this is the second component and third component, something like that, and this one has a, this one is considered as alpha, this one has a high alpha, that means coefficient of thermal expansion is very high in this case. So, this particular thing will expand, correct. So, this will expand. So, diameter is decreased and the length is increased. If this expansion is there, this is highly exaggerated, but you will at least get in few microns. If this is happening, then what will happen? This particular component will move in this direction, this will move in this direction. Since everything is closely packed, even a slight movement here and there will disturb all the assembly, and you will end up with the some permanent deformation into the machine tool. Damping properties, damping property means the capacity of vibration absorption. Vibration absorption. That means, suppose you have one table here, let us consider, and here you have sensor and you are hitting with a hammer at this location. So, you are hitting at this location. So, when you are hitting here and you are measuring the vibration at this location. Okay. So, when you are hitting here, vibration will propagate here and it will reach to this particular location. So, whatever is the property of this particular table, or this is the particular plate, that will dictate that how much vibration will propagate up to this particular point, correct. So, if you are hitting very hard and this particular thing is a very low damping coefficient, and then there is a problem of propagation from this. So, all the vibration will propagate and it will reach to this location and it will continue for a little bit longer time also. So, what we need? We need a damping properties should be very high in this case, so that all the vibration will be absorbed within the material only and it will not reach to the under joint here. If it is reaching to that joint, after some time joint will be little bit loose and then it creates a problem in the other assembly part. Accuracy is important, that we have seen in the last previous 2-3 slides. Throughput is also important, that how many components you are getting, that is called the production rate, rate of processing. Or we can say the production rate, correct. So, that is important, because even if everything is there, we should have reasonable amount of throughput, so that we can actually justify the cost versus the production rate, because the cost of the machine is obviously very high, but if you are not able to extract the required amount of work out of it, your machine will not be useful for different other operations. And easy of use is important, because we know that operation and the things which you have to take care during operating a micro machining is different than the conventional machining. In the last few lectures we have seen those things, but still it should be very easy, because a person should be very he should feel very comfortable while learning the machine also, and it should not have so much of sensory things and understanding the things about the process. So, let me stop from this particular slide and we will continue this topic in the next class, comparing with the other systems and the parts. Thank you very much.